Okay, hello guys, it's Orish, civil engineer student. Okay, today in our new video we are going to do a bit of quantity estimate. We are going to study how to find the number of reinforcement needed for a reinforced concrete slab. First, you have to know that there are many types of slab. You have reinforced concrete slab, you have rivet slab, as the unknown type of slab. And for a reinforced concrete slab, the thickness can vary in between 15 centimeter to 20 centimeter. Okay, so I'm going to as data here we have the spacing of our steel bar, which is 15 centimeter. That's the spacing on this diagram, which is showing the spacing in between the different bar, 15 centimeter. And also you have to know that we will deal with the developed length, which is noted LD, the commercial length, which is called LC, and also in Cameroon, in the case of Cameroon, which is my country, the commercial length here is equal to 12 meter for a steel bar. The commercial length of a steel bar in Cameroon is 12 meter. Okay, so that's the data that we have. This is our reinforced concrete slab. The width is 8 meter, the length is 12 meter. Okay, so first of all, we are going to find the number of steel bar needed in the width in terms of the width direction. Okay, so the number of steel bar. Okay, to have the number of steel bar in the direction of the width, we will have to do the width. Let's call the number of steel bar in the width direction NBW. We will have to do the width divided by the spacing in between two bars. The spacing is 15 centimeter, so we have 8 meters, which is the width. We have 8 meters, which is the width divided by 15. Let's convert it into meter, which is gonna give 0.15. You have 8 meters divided by 0.15 is going to give 53.33. So we have 53.33 bar for in the term of the width direction, but we'll round it up to 53 bar. 53 bar. That's NBW. That's the number of steel bar needed in the direction of the width. And now we'll find the first. We'll find the second thing. The developing length of the bar. The developing length of the bar in the direction of the width. Okay, the developing length for the width. Okay, we'll find the developing length of the steel bar for the width. Okay, which is equal to what? How do we get it? First of all, we have to know that that's how the steel bar look like. You have what we call here hooks. This is hooks. Yeah, that we call it hooks. And to have the final length of one steel bar for the width, we'll have to add to the length of the width, which is already known, which is the width or the length of our the width of our slab, which is 8 meter. The hooks here is equal to 10 centimeter length for the both end. At the both end we have 10 centimeter, which will give a final length for one steel bar for the width will be equal to 8.2 meter. Okay, so the final length of one steel bar in the width direction will be equal to 8.2 meter. Okay, we already know the number of bar that we need for the width. So to have the developed length LD1 for the width, we will write LD1 is equal to the number of bar for the width times what? Times 8.2, which is the length of one steel bar for the width, which is going to give 53 times 8.2. You have 400 4.6 meter, which can be rounded up to 435 meter. So this is the developed length of the steel bar for the steel bar for the width. Okay, now we found the number of steel bar needed for the length of our slab. We will still do the same process. Number of steel bar for the length. Let's call it NBL. Okay, NBL here will be equal to what? Number of steel bar for the length will be equal to, we know the spacing between two bar, so we'll just take the length of the slab, which is 12 meter. The length of the slab, which is 12 meter, we divide the length of the slab, which is 12 meter, by 0.115. By 0.15, it will give us the number of steel bar needed for the length. That's 80 bar. Okay, so the number of steel bar needed for the length is equal to 80. After this, now we found the developed length LD2 for the length. Now the developed length, that's the developed length is this term here is employed to show the length when you join each of those steel bar for the length. So the total length of the bar that you will be using for the length, and the same thing for the width. You have the total. This LD1 represents the total length of the bar using to make the the reinforcement on the width. So you have developed length LD2 for the length. As we did for the width, you have one steel bar which will be horizontally, which can be represented horizontally a bit like this for the length, and there are also hooks here, and the hooks exactly also equal to 10 centimeter. Each hook is equal to 10 centimeter. So, and we know that the width, the length of our slab is 12 meter. So the final length of one steel bar for the length is equal to what? Is equal to 12.2 meter. When you add with the 12 meter plus the 10 centimeter of the hooks, so you have LD2, which is equal to what? Which is equal to 12.2 meter times the number of bar for the length. You have 80 bar, which is going to give you what? 80 times 12.2 is going to give you please let me check this calculation here. The number of bar for the width is as if it's a punching error here. You have 53 times 8.2. Okay, give exactly 435. Okay, so punching the value, we have the developed length will be equal to 12.2 times 80, which is going to give 900, and you have 976 meter. This is the developed length. Okay, LD2 for the width. Okay, so we have the developed length of the steel of the reinforcement for the length and for the width. So we'll find out the total developed length. Find the total developed total developed length TL will be equal to what? TL will be equal to LD1 plus LD2. So we have TL, the total developed, let's call it here TL, the total developed length, or TDL. Let's say TDL. TDL, the total developed length will be equal to 976 plus 435. 976 plus 435. That's the developed length LD1 for the width and the developed length LD2 for the length, which is going to give us 1411 meters. So that's the total developed length. Okay, so we have the total developed length. Now we found now the number of reinforcement of rod needed for the reinforced concrete slab, the one that we can go to the market and say that maybe we need 10 rod of 12 that's 12 millimeter diameter. That's so we will find out the final number of reinforcement needed for our slab of 12 meter by 8 meter. Okay, we find number of rod needed for our slab, for the slab. To have it, we will do the total developed length. The number of rod now, NR, is equal to what? The total developed length of the rod divided by the commercial length, LC, the commercial length of one rod. In Cameroon, I said in Cameroon is 12 meter. It's 12 meter in Cameroon, so we have 1411 divided by 12, which is going to give 17.58, which can be round up to 118 bar, 18 rod. Let's say 18 rod. So the final number of rod that we need for this construction, this slab, to make the decking, we will need 118 rod of, always write it this way, HA 12 118 diameter 12. That's we need 118 HA12. That's 118 steel bar of diameter 12 millimeter of diameter. These two notation are valid for the solution. Okay, so that's how we can determine the number of rod needed for the construction needed to make our decking in the case of a reinforced concrete slab. If you like it, you just like, you leave me a like, you leave a comment. If you have a worry, leave a comment in the comment section. You activate the notification sign symbol, and then wait me for the next video. Thank you.